Welcome. Today we're going to look at arithmetic series. We've previously looked at arithmetic sequences, and in this case this sequence has a common difference of 2. So remember, an arithmetic sequence must have a common difference. What makes it into a series is if we replace the commas with pluses. So in other words, we are adding up each term to find the sum of the series. The notation is capital S with a subscript n, which stands for the sum of the first n terms. So in this case, this sum of the first 4 terms of 5 plus 7 plus 9 plus 11 is 32. Now to move on to some examples. In this question, we are asked to prove that the sum of the first 100 natural numbers, so those are the counting numbers, in other words 1, 2, 3, all the way up to 100, to prove that that sum is 5050. To start with, I'm going to use the notation, the sum of the first 100 numbers is equal to 1 plus 2 plus 3, and that will get quite tedious, so I'm going to skip ahead. So there are 100 numbers. I'm going to use a little trick by writing that again, only this time in reverse. And as we can see here, if we add the left hand side together, we get 2 lots of the sum of 100. And if we add the 2 right hand sides together, we get 101 plus 101 plus 101 all the way to the end. So this could be rewritten as, instead of writing 101 100 times, we could say there are 100 of them. This is looking a bit more like an algebraic equation now. So let's make the sum of 100 the subject. We do that by dividing both sides by 2. And now it becomes either a case of some mental arithmetic or using your calculator to find that the sum is indeed 5050, and we have indeed proven that the sum of the first 100 natural numbers is 5050. Moving on to example 5. This builds on the previous example, only this time we're going to generalize. So we want to create a formula. The formula is going to be the sum of the first n terms is equal to the number of terms divided by 2, in brackets 2 times the first term plus n minus 1 times the common difference. So to prove this formula, which is something you may be required to do in the exam, following the same format as before, the sum of the first n terms is equal to the first term plus the next term in an arithmetic sequence is the first term plus the common difference. To find the next term, we have a plus 2 lots of the common difference. And if we keep going with this, we will get to the nth term. Now the nth term, as we know from before, is a plus n minus 1 d. Following the same process as before, I'm going to rewrite this only in reverse order. Well, working backwards, the second term here would be a plus n minus 2 times d. Coming along to the final one, we would have just the number a, or the first term. Now, adding the 2 left-hand sides, we now have 2 lots of the sum of the first n terms. Adding each term individually, the first one we'll see we have 2a plus n minus 1 times d. Coming on to the next one, again we will have 2 lots of a, and if you were to expand the brackets, nd minus 2d plus another d would then give us n minus 1 times d. Moving along to the final term, you can see that we have 2a plus n minus 1 times d. And here it becomes obvious that each term is the same. Well, how many terms do we have? We have n terms. So we have n lots of 2a plus n minus 1 times d. Now, again, making Sn the subject, we're going to divide both sides by 2. And we have then inside 2a plus n minus 1 in brackets times d. And we have our formula. Moving on to example 6. Now that we have found a formula, and we know it's going to work because we proved it, we can just apply that formula. So in this case, find the sum of the first 50 terms, meaning n is 50. We also know from looking at the series that the first term is 32, and the common difference, well, we go from 32 to 27, so it looks like we're subtracting 5 each time, and just checking that, it does appear to be correct. So our common difference is minus 5. And it's always worth writing those terms out first of all. Now, writing the formula, the sum of n terms, n over 2, 2a plus n minus 1. So it's now, just to fill those values in, we want the sum of the first 50 terms. So 50 over 2, 2 times the first term, 50 minus 1, times the common difference, which is minus 5. And this gives us a total of, because at this point you could just type it all into your calculator, minus 4525. So it is possible for a sum of a series to be negative. Moving on to our final example, example 7. Here we want to find the least number of terms required for the sum of this series to exceed 2000. So let's see what we know first of all. We know that a is 4, and we know that d is 5. What we don't know is the number of terms. And for this, we want to see when the sum of these n terms exceeds, in other words, is bigger than 2000. Well, we know a formula for Sn. That is n over 2, 2 times a, plus n minus 1 times d. So we now have an inequality that we can solve. Filling our values in, n over 2, 2 times 4, n minus 1, and our common difference is 5, bigger than 2000. So I'm going to multiply both sides by 2 first of all, tidy up inside as well, tidying up a bit further, we have 5n plus 3, bigger than 4000. Expanding this out, we have 5n squared plus 3n. I'm going to subtract my 4000 to turn it into an inequality, in fact a quadratic inequality, which is bigger than 0. I'm going to use the quadratic formula to solve this. And this gives me two values of 27.99 or minus 28.59. Now, we're looking for a term number. These have to be positive integers. So we can rule out the right-hand side, which is not negative. On the left-hand side, we want to think, is it going to be 27 or is it going to be 28? Well, one way of thinking about this is to think of the graph. It is a positive n-squared graph, so it is going to look like a U-shape. If this crosses at two different places, the one on the right-hand side This is 27.99. We want to know when this is bigger than 0, so we want to be n is bigger than 27.99. Therefore, n is equal to 28. So at the 28th term, the series will exceed 2000.